One way that we find cells can communicate with each other, one of them is obvious. Earlier on in the year, we had learned that cells that are right beside each other in both plant and animal cells, these cells have the ability to make what they call gap junctions, but basically little gaps in their cell membranes that can allow particles from one cell to freely flow to a cell beside them, and that would be the easiest way for two to communicate if they're right beside each other, actually touching each other, and they can share parts of their cytoplasm. Then one cell can be doing something, and the cell right beside it knows what's happening immediately. Okay, so that's one way that we call this direct contact. It's one form of direct contact on these cells that are stuck beside each other. Another form where cells can actually touch each other is cells that are mobile, or cells that are able to move around the organism. An example being like our immune system cells, our white blood cells. They are patrolling through our lymph system as well as our blood, and they are able to travel, and anytime they bump into something, they are able to recognize that thing or not recognize it, okay? And what this is showing is a cell recognizing another cell based on proteins on the surfaces of the cells. And that is a common form of communication, especially in our immune system, where we are able to identify bacteria and identify that it's no good, and if we can do that, if that communication can happen, then the cell, the white blood cell, will actually launch an entire immune response through that. So these are two examples of direct contact communication. If it's not going to be direct contact communication that's happening, then we have to get to signaling systems, and this is what we're going to spend the majority of the chapter on. But when we have one cell that is releasing a signal that is going to travel some distance and then be picked up by another cell, that signal will be picked up and responded to by another cell. So we have something that they call local signaling here, and that is, again, two cells that are very close to each other. Maybe they are touching, maybe they're not touching, but they're very close to each other, and then they're sending signals, chemical signals to each other to cause responses in the other cells. So the two examples they have here, one of them, as you were reading through the book, talked about growth factors. And that's actually a really interesting one. Like if you get a cut in your skin, the skin cells near the cut, they will actually send out different growth factors. Those growth factors will tell cells in that area, that very localized area, hey, you better start growing and dividing. And so it's one of your body's ways of healing is by saying, hey, if there's something broken, then cells close to the break are going to send out signals that will say, let's start growing and let's start dividing, and then we can start the healing process. So that's one of them, and that's what's shown with this paracrine signaling that they're showing here. And then the other one is in your nerve cells. Two nerve cells that are right beside each other. One nerve has to stimulate the nerve right beside that, and there's actually always a gap between the two nerves. And you'll get into that, I think, a little bit later next semester with Mr. Steiner. But there's a gap between the two nerves, and so chemicals leave one nerve and are picked up by the next nerve and cause changes in the second of the cells in response to what the first cell was telling it. So those are local signaling, cells that are very close to each other. Maybe they aren't touching, but they are at least in the same region. Then the other type of signaling that we have is long-distance signaling, and the most common of these would be hormones. Hormones would be produced in one part of the body and then carried by the blood throughout the entire body. And if they hit cells that recognize whatever the signal that's being sent, then they will do something about that. Okay, so one of the examples on this one, the hormone testosterone, one of the things that happens is as males increase testosterone production once they hit puberty, and the testosterone is made in the testes, that hits the bloodstream, goes throughout the entire body, and it's sending a signal to all kinds of different cells to do all kinds of different things. So muscle cells will start to develop in response to this signal of testosterone. Hair follicles all over the body will start to increase hair production. So all of a sudden guys start getting facial hair, their legs and arms start to get a little bit more hairy, maybe chest hair, back hair, all kinds of, anyway, guys, disgusting and hairy. But anyway, that's all the signal that's sent from one location in the body and is traveling throughout the entire body, doing different things to different parts of the body. And anyway, that's long distance signaling, where something's hitting the bloodstream and going from there.